Okay, this is the CarbonShift Analytics application presentation. I'm going to walk through the application as a user would see it, and then as the product owner or administrator would see it as well. And I'll touch on some other implementation methods as well. I'll have a look at the message broker, but it will be quite a high-level overview. We're going to walk through the logged out sections of the site. We're going to log in. We're going to walk through the logged in sections of the site. How that information is displayed. We're going to walk through setting up a device. We're going to have a look at the shop, the administration interface, and then we're going to have a look at the message broker and the workers. So if we start with the landing page of the site, we can see the village notice board, if you will. This isn't hard-coded. This can be dynamically changed as and when the information needs to change. Some of these are clickable, and users can go to external sites that will show them information that they need. Back on the website, we have a logged out navigation bar for the logged out pages. We've got an About Us section. We've got the shop where users can browse the items available in the shop, but they can't add them to basket and purchase them. And then users can log in or create an account. They can create an account here, and then if it's successful, they'll be directed back to the login page. We're going to log in for a user that's already quite well established in the site, so we've got all the information here to show. So from the dashboard, we can see the carbon generated today by all of the smart plugs at the sublocations and the carbon over the target today. The target was set to 0 for today, so it's the same. The all-time carbon and the all-time carbon over targets are updated by a task sent to the message broker and then executed by one of the workers periodically every day at midnight to update the new day's carbon to 0 and the target to whatever the budget is. But the all-time carbon over target are useful for organizations that might fluctuate in their energy usage and for purchases to be made that offset carbon historically that was generated. We've got our current primary target information. Go to the target section. Users can add new targets. They can set it to whatever they want. We'll set a demo target, and we'll set this to 40. We'll set this value to 48. I think that will demo it quite well. All of these are done in kilograms of carbon produced per day. We'll set that. We can see it here. We'll set that demo target as our primary target. And if we go back to the summary page, we can see here that we've exceeded the target. But if we go back to the target page and we set a lower target, like our COP20 target, as our primary, we go back to the summary page and we 100. There we go. It's just taking a while to reload the page. There we go. Because the target's so much higher, we've only used up a small proportion of it, so we get that in green down here. And the primary target will update the carbon budget for that day appropriately as well. But when the message broker gives a job for the carbon over the target every day to be updated, it will only use the primary target, regardless if the primary target is changed throughout the day. It only matters at that moment in time when the task is done, what sets the budget for the day. We then have 3 graphs. We have the past 24-hour carbon intensity, we have the socket usage from power, and we've got the carbon intensity of each socket as well shown. We can see here I've got 3 plugs plugged in. 2 of them are silly plugged into actually the same device. One's just at the start and end of an extension lead in the kitchen. We've got my laptop charger up here, which is quite a consistent power usage, and then below it we've got a device in the kitchen. It's like a toasty maker that has 2 usages during the night. We can see the spikes there. This was changed in the user review. The good thing about having these graphs and these 3, again, it's talked about more in the report, but users can make the connection between the fluctuating carbon intensity, their socket usage, and then they can see how those trends are impacting the intensity of each socket, and they can see how the carbon intensity is a product of power usage and the carbon intensity, and they can try and create a strategy based on them. If we go to the insights page, when it loads, which we get into the report why it's loading, we can see the forecasted data. This forecast is a very poor one. We're just using the day-to-day trends, so we're using yesterday's trend as today's trend, because I found out quite late into the project, you can't query the forecasted data. You can only query historic data for carbon intensity from the site we're using. And we've got the best and worst times to use power, which is just taken from this graph for the highest and lowest carbon intensity. This is a bad way to predict carbon intensity, but it's not the worst way. This is a general trend that most days the carbon intensity changes quite a lot, but this pattern is quite a standard one for the day. Users can be directed to the full carbon intensity website if they want. This is where we make our API calls. It was this graph that I initially saw when I was doing my research that I realized there was quite a big fluctuation in what made up the energy grid, and there was an opportunity to make carbon savings based on the time of day energy is used. Just while we're here, we'll look at the documentation. And I'll just show you my where I made my big error in forecasting. Along the slide here, you've got the different API calls that you can make. I believe we're using the from and to for most of ours to get, or we're using intensity every 10 minutes to get the carbon intensity. And then we're using the intensity from and to get our predictive data forward in time. But when I was planning it, I saw forward 24 hours and past 24 hours, and I assumed that was from the current time. It's not. It's a average of a 24-hour window from a certain time or back from a certain time, but only historically. So that was where I made my mistake, and it was too late in my project. Again, I get more into this in the report. The targets page, targets can be created, deleted, and set. At the devices page, we can see our devices here. We'll delete device 2 because it has a horrible name that I left for this demonstration. And we can add a new device, and I'll show you how that happens. So we put in the name here, we'll put a description, so we'll go plugged into toaster. And the access ID, access secret, and device ID and API endpoint are all accessed from the TUIA platform. So users have to create a TUIA developer account that attaches to their Internet of Things app on their phone, and then they can get their authorization client ID and secret key from the project overview. And then on the devices page, they can get the specific, once it loads, device ID to make the API call to the specific account. They could have multiple TUIA developer accounts attached, they could have API calls from the CarbonShift application made to multiple TUIA Internet of Things sort of platforms, just as long as those are, because the device ID and user information is set independently for each device. If we go back to the website, we can add devices there. We've got instructions. These are available logged in and logged out. And these were changed as well based on the user evaluation. So users can just work through these here. They can tick them off once they go. Then we'll move on to the shop, which has your carbon balance up here. It's got a little dashboard at the top. Same as the logged out version. Users can have a look at the carbon offset options, and they can add it to basket. The point of this, and I get into it in the report, is that the carbon offset strategies currently vary quite big in successfulness and how they actually work, and some have a really good track record and some don't, and some are cheaper and more expensive, and it's a very gray area. So the point of this store is that users can compare and contrast different options and find out which one is financially and perhaps morally best for them. And it does good. It's ethically a good platform. It's a place for carbon offset companies, which is doing an objectively good thing, removing carbon from the atmosphere, a key goal of this project, to present their options that users can buy and offset their emissions. It also offers a monetization aspect to the site. We're bringing together customers and companies that offer the carbon offset. So if it was to be a deployable product, this is where the money would be made. It would be free to the users because they're already taking on that cost of buying the hardware. This is where it would be in the purchasing of the store, where you take a fee or something. But that's not really a key part of the technical aspect of the project. So if we have a look at some items here, we'll add a few of this to the basket, and let's add some tree planting as well. We'll add that to the basket, and if we view our basket at the moment, we can view the items in it. We can see the total. We can update this as well if we think we don't need it anymore based on the carbon balance and over target. We can proceed to the checkout. everything's bought in kilograms of carbon, and the granularity of the website can't really be changed in this version. But that would be something you'd really want. Different organizations, some would be working in tons of carbon, others kilograms. So that would be an appropriate way to change the website as well. Once the order is placed, obviously this shop isn't functional, but what it does do is it does deduct that carbon from your account. You have bought that offset, so it's deducted the carbon that you've earned, for lack of a better term, from all of your sublocations. In the account settings, you can change your password, you can delete the account, and you can log out. What I'll now show you is the map of how the application connects to the smart plugs themselves. We're making this is quite efficient. I go into this in the report in more detail, but the CarbonShift application is making an API call to the TUIA development server. The TUIA development server is then connected through the internet and through your local area network to your TUIA Internet of Things smart app, and that app connects through your local network to the smart plug. In the report, I look at better ways of doing this. This is an inefficient, albeit a cheap way to connect Internet of Things devices to the application. It works, but there are big limitations to it. And finally, we'll just have a look at the message broker. So we host the message broker locally, and then the producers and consumers are just in other PowerShell windows that run alongside the website as well. So we can see here the beat scheduler. Every 10 minutes, we're making an API call to the carbon intensity website and to all of the smart plugs for every user to create power instances and create carbon intensity instances. And these are saved in the database and are used to generate the insights. Django administration page comes built in with Django's applications. We're just registering our models with it. But what's good about it is that aspects like the shop and like the power, the information tile, can be dynamic and can change based on how the administrator wants the website to be, which is good because this is designed. One of the requirements was that it's a business application and that the owners of it and the developers should be able to change things, change the information available, and change the products available as and when the market changes. Django is a good option for that. This comes built in. It's quite powerful for development, but also for the business aspect of the project. And that's the end of my presentation.